I think this follows on very well from what Peter's just been outlining. I've got the ensuring critical skills development for the future title, and I'm just going to go through that. But I think implicit in that question is the assumption that a future structural engineer will have to work in a very different way. Otherwise, you would say, well, we should be ensuring critical skills today, not for the future. But I'm going to focus on how I think things might change and where we need to change our skills in education to match that. And the caveat being that the iStruct has a digital workflows and computational design panel, and I'm part of a subgroup looking at the future competencies, which is some work along these same lines. So watch this space as far as the iStruct is concerned. But today, I'm just going to start by saying really that I've seen all this before. I was in Bureau Happold when the last drawing board was ceremonially taken out of the office to make way for CAD. And after CAD, I was there when BIM started coming to take over. It actually took legislation really to force people to leave CAD behind, but we got there in the end. And more recently, I think BIM is being taken over by parametric modeling, and I think they're all positive steps personally. So I'm not panicking yet. But in terms of it makes me feel a bit old saying I've seen all this before, but I just see really linking to the curve that Peter showed it. This is just the next big thing. So I'll look at the question how we can ensure critical skills to cope with this next biggest thing. But I think I'm taking a broader view than just that. Now, of course, we can just stick AI onto the curriculum, right? And if you Google MSc in AI, there are loads. The best one being our new one at the University of Bath, of course. And at Bath, we're also, I would say, leading HE with our AI and assessment policy. Lots have caught up, but during COVID even, we had a team in the Centre for Learning and Teaching looking at AI and how we can make sure students' work is their own. And we've categorized all of our assessments as A, B, or C. A, generative AI is not permitted. B is permitted for specific processes. And C, it's actually mandatory in part of the assessment. And we have an expectation as teachers that everything will at least be B. So we're sort of embracing AI use and just allowing it within certain situations. And we're also embedding critical skills within our assessment that align with AI. Peter said he'd heard of one, and it might even be mine that he's heard of. The example is a colleague of mine, Andrew Heath, his geotechnics exam. His exam question is, I shoved this question into ChatGPT and this is the answer it gave, and asks the students to critique that answer. So if you can't beat them, join them, right? We can't get rid of AI, but we should teach them in context how to use it sensibly. And another thing to consider as well is maybe we don't even need to put it into a curriculum. Maybe students are doing it, working it out for themselves anyway. We can just leave them to it. This was brought to my attention by my son, actually, which shows the number of AI requests dropping off a cliff, coincidentally in line with the end of the university semesters and the school terms. So it's tentative evidence to say that students are a big user of AI as part of their coursework. And there's a JISC survey come out that said 34% of students were using AI tools to learn, and 23% had got those tools provided them by their institution. So there's, there's evidence there that it's being done, and there's also evidence that students are doing it anyway, whether or not their institution is supporting them. So I think that to wrap that part up, I think we've got AI, it's out there, we've got to embrace it, we've got to look at what the students need to get the best out of it, and look at what we maybe need to help them to make sure they don't fall in some of the pitfalls that Peter outlined. But there's a big but here, and that is that the curriculum is finite, and a few people have mentioned it, and I think in a way we should look at what we have to remove. Sustainability was a big thing, and it got embedded in our curriculum, but then, you know, what could we move or merge or make room for, and all the next, every time there's a new thing that engineers need to know, we don't necessarily look at actually what do they not need to know anymore. And if you forgive a Monty Python reference, we could say, well, come on, AI is wafer thin, we'll just sneak it in and nothing needs to give, but that's not always the case. So I thought a little bit about maybe what engineers don't need to know anymore. Some of these contradict Jonathan Carr's thoughts on technical skills from earlier that he was outlining, but I don't mind. I'm happy to be controversial, and I did wonder whether our graduates need to know maths anymore. Right now, I've got a maths degree, so I'm not coming at this from a particular point of view that, you know, maths is for mathematicians, and the maths I did was very abstract. But what maths do our grads actually need? And I think I've seen it being watered down, let's say, for want of a better term, over the years. And even now we've got, you know, do they need to do hand calcs? We've got Excel, we've got Python, can do it. So I think we need to consider exactly whether we're confident that we know what maths an engineer actually needs and what maths an engineer doesn't need. And perhaps more controversially, design codes. Well, computers love applying well-defined rules over and over again 1,000 times a second. So why don't we let them? Do engineers really need to know design codes? I'll leave that out there. More interestingly, what do they no longer need to understand? Someone mentioned first principles before. Do engineers need to know first principles? Good job you're all muted, so I can't hear huge shouts of yes, of course. But you know, I had a student who handed coursework in which had a kilometer deep beam in it. Now, they'd got the units wrong, right? But they didn't check it. They didn't have a sort of first principles knowledge to go, actually, does that look right? It links to some of the stuff Peter Debney's published previously on how to check and validate finite element analysis. But, you know, first principles, bendy moment diagrams, very well defined. What do students actually need to know in that space? And some work I did with the universities of Edinburgh and Sheffield a few years ago, which you can watch a fabulous video on at the iStruct a few years ago. But we asked practitioners the answer to the most simple question we could think of about strut and tie modeling. So just axial forces and no bending. And what's the simplest, least material structure to take a load between 2 points? And we actually got a huge range of answers. Now, these are practicing engineers. You would expect that if you went down the road and said, design me you know, a beam, everyone would agree what the answer was. For those of you who don't like homework, the answer's half a bicycle wheel, but some very obvious common solutions are significantly heavier, and the amount heavier can be up to 50% depending on the question you ask. But what I'm trying to say here is actually that what the real optimum is perhaps not intuitive. AI is only good at guessing the things it's seen before. So if we embed an engineer's, in quotes, knowledge into it, then it will just guess what it's seen before. So we need to be careful on how we train these things. And we need people we say people need to understand structures, but do they actually understand structures? And the other thing is whether engineers really understand what their goal is. I've got this brilliant quote, which I can say is brilliant. I was blown away by it. Possibly the most common error of a smart engineer is to optimize a thing that does not exist. I was blown away by that until I found out who said it. But there's a more structurally engineering version of the same thing by former ISTRUCT president Alan Harris, who said it's not how big a beam is, but whether to have a beam in the first place. How many times have you asked someone to size a beam and the answer came back as 0? So I think we engineers really need to think and understand about what their goal is. Do they understand it? Do we need to teach them, or can we just assume that they know what their goals are? And some of the research I've been doing more recently at Bath is on people-led research, in terms of looking at new technology and looking at the barriers to adoption of new technology. And they often tend to be more about getting the people on board rather than inventing a new technical tool or a widget. So I think engineers need to really think about what their goal is and what they're trying to achieve before they start trying to achieve it. And the last part of this is what engineers no longer need to be able to do. There was an article in Wired recently called "The End of Handwriting." So, all right, I don't teach my undergrads how to do handwriting. I assume they can do that before they arrive. But do we need to teach them handwriting in primary school? We can free up some of that curriculum and teach them engineering in primary school instead. Spelling is another one. So we don't need to handwrite it, but we do need to spell it right. This came from a discussion in the pub I had with someone who was asking where to draw the line, what's acceptable of student use on coursework and what's not acceptable and called plagiarism. And I thought back, well, we don't need AI to help us with our spelling, because Word will underline a spelling mistake for us. And not only that, but it will correct it for us. So we've had our spelling corrected. Is that cheating? Generally, people say no. How about a thesaurus? If we use the built-in thesaurus and swap critical skills for critical competences, have we cheated? People would probably say no. But then when we asked ChatGPT, I took the title of this talk and asked it if it could suggest a more sexier title, and it came up with some. Is that cheating? Now, I'm not, a synonym is a replacement of one word. This is a replacement of the whole title. Is that cheating? We've got to decide what engineers, do they need to be able to still use their brain in this way, or can we just let the computer take over from it? A more practical example is surveying. We've got our students out at the moment, I believe, doing the surveying course. And, they've got levels and rulers and tape measures. Do they need to be able to do that? We've got a laser scanner in the department, job done, right? I spent many years doing finite element analysis. Takes days, hours, weeks, months to analyze a slab. You can see the robot making our curved acorn shell, which you can find out more about there. This was spraying concrete and it set very quickly. So we had to do some finite element analysis quickly to work out whether the defects from a scan meant that we should correct for it, or we could just print the next layer straight away. And that means we need an answer within a minute, and FE's slower than that. So a PhD student of mine, Maxime, trained an AI on thousands and thousands, tens of thousands of FE models, and now we can decide whether that thing is going to work or not within seconds. So maybe we don't need to do analysis anymore, or we don't need to do it live anymore once we've trained an AI in it. And the building. A project of mine with Imperial College and UCL looked at 3D printing drones. That is drones doing the 3D printing, not making the drones. A rather silly idea, but if you were going to make a base on Mars, you could make it now before the humans get there. So we're going to automate the construction process. We're going to do a lot more off-site in factories. Do we need to teach people how to put things together, or can we just press print? And on the same project, UCL focused on project management. we were envisaging hundreds of drones building a structure. So they were looking at job scheduling and how we can get drones not to crash into each other, but how they can take jobs, print them, optimize the actual on-site work. And so maybe we don't need project management anymore. We can hive that off to the AI. Some thoughts, controversial maybe, but I think it just comes from the fact that I've seen this before. I've seen the introduction of disruptive technology before. I'll see it again. This is my horizon scanning of the technology that's coming along. All these things is going to come along. And what I don't want to be is having to update this talk every 5 years to say, ensuring critical skills for the future because graphene is existing or because we're running out of water. So I think we should just really step back, take a holistic view and say, how can we fix this once and for all and not keep going through Peter's curve of hype and depression? So what do we need to do? I'm going to leave it till the panel discussion after the break to tell us how to do it, because that's the hard part. But here are some of my thoughts on what we need to do. And I think I'm starting from the point of stop reactively chasing the next big thing. We were talking in the Senate meeting a few months ago, just reflecting on how slow universities are to change. And if it takes about 2 years to actually propose a change to a curriculum and get it through the committees, and then 4 years for the first graduates to hit the job market, by the time the next big thing's sorted out, it's the last big thing and there's a new one. So let's stop reactively chasing the next big thing and sort this out. And I think we need all the things on the screen. And that's not to say we need adaptive, intelligent, resilient, sustainable buildings. We need adaptive, intelligent, resilient graduates entering the profession. That is, graduates entering the profession. Once we've got these fabulous graduates, we don't want them to disappear off and become bankers or politicians. We want them to stay in engineering and carry on with that fantastic career. To do that, I think we might need the same campuses, institutions, societies, planets, and given my drone slide solar system, we can't really expect our graduates to be resilient and ethical if our campus isn't. And this does align with a lot of the non-technical skills that Jonathan presented earlier. And so I think we need to work collaboratively with other institutions to reclaim the term engineer. I actually have a plumber coming to knock on the door later. It's not a boiler engineer, he's a plumber. So we need to say what an engineer is and be proud of that term. And I think a lot of the things I've said today could apply to other engineering professions, not just structures. I think we need to upskill previous and current generations. Previous meaning someone mentioned earlier about getting our students to do X, Y, and Z, but these technologies are coming along quickly, and the bosses of the students and the bosses of the bosses of the students need upskilling so that they can take advantage of it. So maybe we need to look at micro-credentials to upskill the current managers and senior managers, as well as changing our university curriculums. And we need to work with the next generation to inspire the generation after. This is a long-term thing. I think we really need to think hard about how we can solve it once and for all, and not just keep going through the same discussions over and over again. That's me done. Peter left you with some recommendations, so I have two. I don't have my own book to plug, so I put Flatland in there, which I think is brilliant. But there's a really interesting book by Susskind called A World Without Work, which is great. There's another one called The Future of the Professions, which might be better, but I haven't read that one, so I'm recommending A World Without Work. There's The Future of Structural Design by my new colleague, James Norman. And there is a link there to some of the work that Bath University's done on how students can navigate Gen AI. or even better, just send your graduates onto our MSc in AI and we'll sort it all out for you. That's me done. Thanks very much, and I look forward to listening to the panel discussion where they're going to tell us how we can achieve all this.